Welcome to Chapter 14, Introduction to Inference. These are the topics that we're going to discuss in this chapter. Reasoning of statistical estimation, where statistical estimation is just confidence intervals, doing confidence intervals. We're going to talk about the margin of error and the confidence level. How do we make confidence intervals for a population mean? Then reasoning, the reasoning behind tests of significance or hypothesis testing. We're going to learn how to state hypotheses, the p-value and statistical significance, tests for a population mean, and significance from a table. Now, statistical inference provides methods for drawing conclusions about a population from a sample. We've talked about that before. Now, because a different sample might lead to different conclusions, we can't be certain that our conclusions are correct. So we use statistical inference and the language of probability to say how reliable our conclusions are. Now, confidence intervals and hypothesis testing, or test of significance, are two of the most common types of statistical inference. Both are based on the sampling distribution of the sample mean. So we have to have a good grasp of Chapter 11 when we start in on Chapter 14. Now, in this chapter, we're going to start with a very simplistic setting. Here it is. We have a simple random sample from a population of interest. There is no non-response or other practical difficulty. Number two, the variable we measure has an exact normal distribution in the population. And the third thing is, although we don't know what the mean is, we know what the population standard deviation is. These are the assumptions we are going to make in this chapter. So let's go back and do a little review about sampling distributions. Now remember that the mean of our sampling distribution is of a certain sample size is equal to the population mean. And that the standard deviation for our sampling distribution of the sample means is just the standard deviation of the population divided by the square root of the sample size. Now, if you remember back in Chapter 3, we talked about having 95% of the data in between two numbers and thus about plus and minus 2 standard deviations. But when we use Table A, we can get a little more precise. So we find that between negative 1.96 and positive 1.96, about 95% of the sample means would fall in between those two numbers. And, well, of the mean would fall in between those two numbers. In the sampling distribution, we could actually find out what those numbers are by taking the mean minus this product, 1.96 times the standard error. And this is going to be the basis of making a confidence interval. Now, if the sample mean is within plus or minus this 1.96 times the standard error of the population mean 95% of the time, then we can flip this around to say that the population mean is within plus or minus 1.96 times the standard error, that sigma over the square root of n, of the sample mean 95% of the time. And we can mathematically show that these two equations are true. So what we're going to do is we're going to capture the population mean in between this sample mean minus 1.96 times the standard error, and then the mean plus 1.96 times the standard error, that sigma over the square root of n. So we'll have an actual interval, and we'll have a certain confidence that we captured the mean. And that's this, in this case, we're talking about a 95% confidence. And what that confidence means is that if I do samples of whatever size, of size n, over and over and over again, 95% of them would truly capture the true population mean. So in making the confidence interval, the 95% confidence interval, you would say the mean that you calculated in your sample plus or minus 1.96 times sigma over the square root of n. So you do this product and subtract it from your mean, then you take that product and add it to the mean so that you get an interval. But this number, 1.96 times sigma divided by the square root of n, is called your margin of error. It is that number that you add and subtract from your sample mean. So it is basically the half-width of your confidence interval. So the margin of error times 2 would give you the total length of your confidence interval. Now, what proportion of the time does the confidence interval contain the sample mean? Well, it would contain it all the time because the confidence interval is built around the sample mean. Now, if we want to compute a 90% confidence interval or a 99% confidence interval, we would just need to find the right standard normal value. Now, how do we find that? Well, we're going to have a certain confidence level for our confidence interval. And the way we do this is we say 1 minus alpha times 100% gives us our confidence level. So a 99% confidence interval, our confidence level is 99%, we can find critical values for that. So let's look at this picture. The blue area is 95%. We needed to find those Z numbers that correspond to having 95% in between. And that number would be, we'd have to find that number. So if 95% is supposed to be in the middle, how much is left? 5%. And we have to divide that up among both sides. So each of those non-blue areas are 0.025 or 2.5%, because both of those together would give you a remaining 5%. So now I can find the Z number that goes with 0.025, and that's where we got the 1.96. So here are the critical values for the different confidence levels that are seen most commonly in real life. A 90% confidence interval has a critical value of 1.645. A 95% confidence interval, the critical value is 1.96. And the 99% confidence interval, it has a critical value of 2.575. And again, we could find these using our standard normal table, where when we see 90% confidence interval, that leaves us 10 on either end, so we have to divide 10 by 2, and then that would give us 5.05. So we look in the chart for the number closest to 0.05. Remember, we get 1.64 and 1.645, so we have to get the average of those two since the probabilities are exactly, that 0.05 is exactly in between those two areas. So our critical value is the 1.645. Now these different critical values for the 90, 95, and 99 confidence intervals, you ought to make sure that that's on your formula sheet, because that's something that we want you to have. So here is the general form of a confidence interval. You would say X bar plus or minus that critical value depends on your confidence level, times the standard error. So you would subtract that product off of your mean, and you would add that product to the mean, and that would give you the endpoints of your confidence interval. So for a particular confidence interval, the correct interpretation of it is that if you constructed the confidence interval in this way over and over and over again, about whatever confidence level you have percent of the time, your confidence interval will contain the mean. Now in the next slides, we're going to go over and do some examples.